Ancient farmers grew vegetables with twice the protein and 3 times the iron of anything we eat today. Then we threw them all away. Picture this: 12,800 years ago, the world was ending. Not slowly, not gradually, but in the span of a human lifetime. Imagine waking up one morning and it's 15 degrees colder than yesterday, and it stays that way for the next 1,000 years. Ice sheets advanced, rainfall vanished, and the wild plants that had sustained human populations for millennia simply disappeared. Most humans should have died. Instead, something remarkable happened at a small settlement along the Euphrates River in what's now Syria. The people of Abu Huraira did something no human had ever done before. They looked at the withering landscape and decided to fight back. Andrew Moore's excavation team found evidence of over 100 different plant species being systematically cultivated at the site. But these weren't random experiments. The grain samples revealed something extraordinary. And I'm talking about prehistoric farmers who were basically doing genetic engineering with stone tools. They created wild rye with seeds larger than modern varieties, protein content that would make today's health food companies jealous, and drought resistance that puts our crops to shame. But this was just the beginning of their agricultural wizardry. This was the world's first agricultural revolution, born not from abundance but from desperation, and the crops they developed were evolutionary masterpieces. Now here's where this story gets absolutely wild. Fast forward several thousand years to eastern North America, where indigenous farmers built an agricultural empire so advanced that it makes our modern farming look primitive. Most people think Native American agriculture was just corn, beans, and squash. They're missing the biggest agricultural secret in human history. At the center of this system was a plant with the most boring name ever: marsh elder. But don't let the name fool you, because this was basically prehistoric superfood rocket fuel. We're talking oil levels that made sunflowers jealous and protein that would make quinoa cry. So why did they throw away this nutritional gold mine? For 2 millennia, indigenous farmers across the Mississippi River basin cultivated this crop with the precision of master botanists. Picture this. You've got the most nutritious crop in human history. It's feeding your entire civilization, and then it starts trying to kill you. Every harvest season turned into a nightmare of rashes, breathing problems, and basically plant-induced torture. It's like Mother Nature played the cruelest joke in agricultural history. So they abandoned it, not because it was inadequate, because it was too good at being a plant. Alongside marsh elder grew goosefoot, a remarkable dual-purpose crop that provided both protein-rich seeds and spinach-like leaves. When grown together with erect knotweed, these crops created a polyculture system that was 20% more productive than either plant grown alone. They essentially created a self-optimizing agricultural ecosystem that could adapt to climate variations in real time. The most brilliant part: little barley served as their insurance policy. This drought-resistant grain filled the crucial hunger gap in late spring when winter stores ran low, but summer crops weren't ready. It could grow in marginal soils where nothing else would survive, providing high-protein nutrition exactly when people needed it most. This entire system was abandoned not because it failed, but because maize offered higher yields per acre. Productivity trumped nutrition, sustainability, and environmental adaptation. It was the first green revolution, and just like the modern one, it prioritized quantity over quality. The genetic analysis of 6,000-year-old barley from Yoram Cave revealed something terrifying. Ancient varieties contained 73% higher protein, 82% higher iron, 90% higher calcium, and 47% higher phosphorus than modern grains. Put simply, if ancient grain was a superhero, modern grain would be its sickly cousin who never leaves the house. And we chose the sickly cousin. Take amaranth, the sacred grain of the Aztecs. This remarkable plant produces seeds with 14% protein content, nearly double that of corn and rice. It's the only grain that contains vitamin C and provides complete protein with all essential amino acids. The leaves have anti-cancer properties, and the entire plant can grow in conditions that would kill wheat. Spanish conquistadors didn't ban amaranth because it was worthless. They banned it because it threatened their control. 400 years of suppression nearly drove one of the world's most nutritious crops to extinction. While we struggle with climate change and water scarcity, ancient farmers had already solved these problems. Pearl millet from West Africa could survive droughts that lasted months, thriving in sandy soils where modern crops would wither and die. The grain stored naturally for 5 years without any chemical treatments, providing long-term food security that our fresh-obsessed food system can't match. In the Ethiopian highlands, farmers developed teff varieties that provided more protein and fiber than brown rice, while growing in conditions that ranged from sea level to 4,000 meters elevation. These plants tolerated temperature swings from 8 to 40 degrees Celsius and could grow in poor rocky soils. Perhaps most remarkably, Chinese farmers 8,000 years ago developed foxtail and broomcorn millets that matured in just 90 days compared to the 120-plus days required by most traditional crops. These grains served as climate insurance. When monsoons failed or temperatures fluctuated, the millets would still produce a harvest. The truly sophisticated part was maslin cultivation, deliberately mixing different grain species in the same field. This wasn't primitive farming. It was complex systems thinking. When drought hit, the drought-resistant varieties would dominate. When conditions were ideal, the high-yield varieties would take over. The field essentially reprogrammed itself based on environmental conditions, producing 20% higher yields than monocultures while providing built-in pest and disease resistance. Right now, as you're watching this video, there are literal treasure chests sitting in museum basements that could solve world hunger. I'm talking about 4 million botanical specimens at the Burke Museum and 170,000 more at Yale, each one potentially holding the genetic key to crops that could feed the world. But here's the problem nobody wants to talk about. Scientists have basically figured out how to bring the dead back to life. I'm not talking zombies. I'm talking about reconstructing the complete DNA of crops that vanished thousands of years ago. It's like CSI for vegetables, and what they're finding is absolutely mind-blowing. The 8,400-year-old wheat DNA from Çatalhöyük in Turkey revealed early domestication characteristics with genetic markers that modern varieties have completely lost. But here's what's truly exciting. Compound-specific isotope analysis can now identify superior metabolic pathways in charred plant remains. Scientists can literally decode how ancient crops processed water more efficiently, adapted to poor soils better, and resisted pests more effectively than modern varieties. This isn't just historical curiosity. Researchers are using this genetic information to develop new climate-resilient crops through de novo domestication, essentially fast-tracking the domestication process using gene editing to recreate the beneficial traits that ancient farmers spent millennia developing. Okay, this next part is going to mess with your head. Out of 7,000 edible plants on Earth, humans only domesticated 200. That means we ignored 6,800 potential food sources. What if we missed something incredible? What if the cure for hunger was sitting right there and we just walked past it? The pre-domestication cultivation period reveals something extraordinary. For over 1,000 years, people cultivated morphologically wild plants, plants that looked completely wild but were being systematically managed. This suggests cultivation techniques so sophisticated that we can't even recognize them in the archaeological record. Recent discoveries are revealing that crops moved across continents before they were fully domesticated. Bronze Age trade networks 3,500 years ago connected regions thousands of miles apart, creating a global exchange system for agricultural innovations. Ancient farmers were sharing genetic resources and cultivation techniques on a scale that rivals modern agriculture. But perhaps the most important question is this: why did we abandon agricultural systems that were more sustainable, more nutritious, and more environmentally resilient than what we have today? The answer isn't agricultural failure, it's systematic suppression. Colonial authorities destroyed indigenous food systems not because they were deficient, but because they were different. The Spanish didn't just ban amaranth, they executed people caught growing it. The Eastern agricultural complex wasn't replaced by superior crops, it was displaced by European preferences for familiar grains in a colonial system that prioritized export crops over local nutrition. Marsh elder, goosefoot, and little barley disappeared not because maize was better, but because maize fit European agricultural models and trade systems. Even the Green Revolution of the 1960s prioritized yield over nutrition, sustainability, and genetic diversity. We traded crop resilience for productivity, nutritional density for shelf life, and environmental adaptation for uniformity. The result is a global food system built on genetic monocultures that are increasingly vulnerable to climate change, dependent on chemical inputs, and producing food with declining nutritional value. But there's hope. Research institutions worldwide are launching initiatives to recover this lost agricultural knowledge. The International Work Group for Paleoethnobotany coordinates global efforts to decode ancient farming techniques. Machine learning applications are automating the analysis of archaeological plant remains, accelerating the pace of discovery. Some ancient crops are already making comebacks. Quinoa has exploded from Andean specialty to global superfood. Heritage wheat varieties are being revived by artisan bakers who recognize their superior flavor and nutrition. Amaranth is slowly returning to cultivation as people rediscover its remarkable properties. The National Science Foundation allocates nearly $1 million annually to archaeological programs focused on agricultural origins. The European Research Council funds major initiatives on comparative pathways to agriculture and prehistoric food globalization. These investments reflect growing recognition that our agricultural future might be hidden in our archaeological past. Modern genetic techniques can now accelerate the redevelopment of lost crop varieties. Researchers are using ancient DNA to guide breeding programs, compound-specific isotope analysis to identify beneficial traits, and geometric morphometrics to understand how ancient crops differed from modern varieties. Here's the truth that'll change how you look at every vegetable aisle forever. We didn't abandon these crops because they were substandard. We abandoned them for political, cultural, and short-term economic reasons that had nothing to do with agricultural merit. Colonial suppression eliminated amaranth and quinoa despite their superior nutrition. The Eastern agricultural complex was replaced by maize for political and yield reasons, not because it was nutritionally or environmentally superior. Ancient wheat varieties were discarded during the Green Revolution's single-minded focus on yield. Today, as we face climate change, soil degradation, and rising malnutrition rates, these ancient solutions offer proven pathways forward. Crops that survived ice ages and droughts, grains that provided complete nutrition in harsh environments, agricultural systems that worked with ecosystems instead of against them. The most remarkable thing about these prehistoric vegetables isn't that they existed. It's that we were smart enough to develop them once and foolish enough to throw them away. The question now is whether we're wise enough to bring them back. The archaeologist who found those charred seeds at Abu Huraira couldn't have known she was uncovering the blueprint for humanity's agricultural future. But in those ancient grains lay the genetic keys to feeding a warming world, if we have the courage to unlock them.